Okay, guys, can you hear me? Just to thank you. Okay. Good morning, everyone. So today we will take a look at integration, double integrals. Okay. Uh, so double integrals, we need to understand what they are, and then see how we can calculate them. First, before we look at double integration, I want to take a look at the simple integrals. Like you have a function here, y equal f of x, and if you integrate the function from a to b, from this point A to this point B, yeah, you integrate it. The integral, you can write it like this. What does this integral represent? You must have seen this before many, many times. What does this integral represent? Okay, let me. The area. Thank you very much. Thank you. Yes. So it represents the area under the curve. Yeah. It actually represents all this area that you see here. Yeah. This area under the curve will be found by finding the integral. Now, basically, that area, because it's not something we can calculate using geometry. So what we do really is divide into small rectangles like this. You can see that there are many rectangles. In each rectangle, this is what happens. You take a point C from this x to this x, and then you find the value of the function at the point C. So Ci, f of Ci, and then you multiply f of Ci, which is this number, by delta x, which is this number. This is delta x, and this is f of Ci. When you multiply these two, you will get the area of one rectangle. Yeah, you get the area of one rectangle, and then you add these rectangles like this, the sum of those rectangles, and then as you take more and more rectangles, basically we take the limit of this sum. As n goes to infinity, you will get the integral like this. So the integral comes from the sum of some areas of rectangles. Now, in functions with two variables, a similar thing happens. This time, of course, the region, it's not from A to B, but it's over a certain region like this. Here, it's a rectangle. You divide that into small rectangles or squares like this. And then in each square, you take a point. Yeah, in each one, you take a point. Yeah. This point this time has two coordinates. Yeah, it has two coordinates. And then you multiply that by the area of the base. So what you have is this area, which is delta A, and then you multiply it by the value of f. That will give you the volume. This time, what we're getting is volumes of cubes like this. So we're getting the volumes of each one of these. And by adding the volumes, you will get the total volume of the required thing. Okay, so This is just a general introduction to double integrals. So it's basically volumes. The double integral represent a volume. And now I want to pass through all of this. No need to bother ourselves with this. Now I want to show you how to calculate the double integral of a function over a region R, which is here given by a rectangle. So let me just show you how to calculate this integral. So R is the region where x goes from 0 to 2 and y goes from 1 to 4. 1 to 4. 1, 4. So basically, our region is this one here. This is R. Okay. So I want to find the integral of the function 6x squared plus 4x y cubed. Because it's a double integral, we use dA. And I want to find this integral over the region R, which is this rectangle. Now look carefully at the rectangle. If you are in the rectangle, x will go from which value to which value. So I'm going to split this integral into two integrals. Yes, first with respect to x from 0 to 2. So I will integrate my function 6x squared plus 4xy cubed. First I will integrate with respect to x, and then I will integrate the answer with respect to y, yeah, dy after that. And y, you can see, will go from 1 to 4. Thank you. Yes, like this. So that's how we evaluate this kind of double integrals. First, with respect to x. By the way, I could do with respect to y first. That's also okay in this example. So now let me try to calculate this. So leave 1 to 4 like that. Now I need to integrate this with respect to x. What is the integral of 6x squared with respect to x? Yeah, 6x cubed, yeah, 6 x power 3 over 3. Good. Plus the integral of 4x y cubed with respect to x. Basically 4y cubed is a constant, leave it there. And x, what do you get when you integrate x? Yeah, x squared, yeah, over 2. Yes, thank you. Like this. Exactly. From 0 to 2. The next step now is to calculate this. So let me put 1 to 4. So substitute inside, yeah? You may remember that's how we calculate these things. So if you substitute, you will have x cubed, which is where, yeah, x is 2, yes? So it's going to be 16, yeah, thank you, 16, and then plus, substitute again 2 here, you will get 4 divided by 2 is 2 times 4 is 8, so 8, yeah, 8y cubed minus, so let me put this is x, yeah, x equal 2, x equals 0. If you substitute x here with 0, you will see that you will get 0. So all of this is 0, and then dy like this. After that, it's a really simple thing. Now I need to integrate with respect to y now. Okay? With respect to y. This is nothing. So 8y cubed, yes, substitute x equal 2 here. Yeah, take x equal 2 and substitute it here. So you will have 4y cubed 2 squared divided by 2. Salha, are you okay? Yes? So it's 4 times 4, 16, divided by 2 is 8. So you will get 8y cubed. After that, we now integrate with respect to y. So 16, what do you get when you integrate 16? With 16y, huh? With 16y, good. Okay, and then 8y cubed, when you integrate it with respect to y, so it's 8, which is a constant, and y 4 over 4, yeah, and then from 1 to 4. Of course, this 8 divided by 4, you can just put 2 there if you want, yeah? So that's okay. And then you substitute y by 4. So it's going to be basically, yeah, 16 times 4, yeah, plus 4, 4 to the power of 4, minus, we substitute, yeah, y with 1, like this, and you put all of this in your calculator, and you will see that we will get, I think 558 is the correct answer. Yes, 558. Are we okay with this? All right, let me, before I, yeah, let me do another example. Perhaps I will go to the end, and I want to do one other example. Yeah, yes, here is an example which is similar. This time the region is x goes from 0 to 2, y goes from 0 to 3. So I want to find the double integral 1 minus y exy dA. So this time I need to integrate with respect, yeah, so it will be 1 minus y exy dx. So integrate with respect to x first, from what to what? From 0 to 2, so 0 to 2. Yeah. And then with respect to y, from 0 to 3. Okay. So let's see how we can do that, how we can calculate this. Okay, leave 0 to 3 there. Now I want to integrate this function with respect to x. What is the integral of 1? X, good, x. Then minus this one is like, think of xy, no, think of xy as a u. What do you get when you differentiate xy with respect to x? With respect to x, huh? Differentiate xy with respect to x, you will get y. Yes. So this is a bit like the integral of the derivative e to the power of u, which is just e to the power of u plus a constant. It's like this. So really, what you have there is just exy from 0 to 2. I need to put x equal so that we don't confuse it with y, yeah? And then integrate what we get with respect to y. Okay, so now we can complete this without too many problems. Yeah, if you want, let me say this. If you have exy, yeah, and you want, let's say I call this function, not u perhaps, no. Let's say you call this function g, yeah, g of x. What is its derivative? With respect to x, huh? With respect to x. What is the derivative of this function with respect to x? Not multiplied by x, multiplied by y. Yes, it's going to be y. The derivative of this with respect to x is y. So it's going to be y exy. So this is g, this is g dash. So if you integrate this, you get this. This is the derivative, this is the integral. So if you integrate this function, you will get this one. So this is why we are putting exy here. Are you okay with that? Like this, yes. Okay, now we substitute now x equal 2 in our function, also x equals 0 also in the function. So this will give us with 2, so the integral from 0 to 3, if I put x equal 2, so yeah, it's 2 minus e to y, like that, minus, let me remove some of this stuff here, minus, when I substitute with 0, yes, so it's going to be plus 1 perhaps, yes, in the end, minus, yeah, it's going to be, let me write it, yeah, so minus, and if I substitute x equals 0, I get minus 1, like this, dy. So now I can say it's the integral from 0 to 3 of 3, yeah, of 3, yeah, minus e to y dy. Okay, and now we integrate, so it's going to be 3y, yeah, 3y, and the integral of e to y with respect to y. If you integrate this with respect to y, let me give you a rule here. Yeah, half, exactly. Yes, thank you. So half of e to y from 0 to 3. In general, by the way, the integral of e ax dx is 1 over a e ax, yeah, plus a constant. This, some rules of integration. Now we substitute with 3, it will give us 9 minus half of e to the power of 6, and then minus, with 0, it's going to be minus half. Yeah. So in the end, it's what, 9.5, 9 plus half minus half e to the power of 6. You can leave it like this, or you can use your calculator. Mind you, this e to the power of 6 is a really big number. It's this is going to be a really big negative numbers, huh? Or yeah, something like that. Yes. Okay, that's basically the way we integrate in a rectangle. So when you are integrating in a rectangle, then it's fairly simple. Yeah, you integrate with respect to x or with respect to y, it doesn't matter. The rest is just like calculus 1 thing. So basically what we do is we split the double integral into two integrals. First with respect to x and then with respect to y, or it's okay also with respect to y and then with respect to x. That's perfectly fine. So either way is okay. It just depends. Sometimes it's easy to start with x and then do y. Sometimes it's easier to start with the y. It just depends on. Now, in general, if you have a region R which is not a rectangle, but between two curves like this, y equal g1 to another curve y equal g2. So the region R is given by this, and x goes from A to B. Then you have no choice. First, you integrate with respect to y. Yes. Yeah. I don't know. What are you saying? I'm not sure what you mean. Okay. So in this uh, kind of figures, in this kind of shapes, you must integrate first with respect to y. So first y and then x. It has to be like this. And the y from g1 to g2, and then x from A to B, like this. So you need to do it in that order. First with respect to the y, and then with respect to the x. Okay. All right. Now let's see. Let's see here. Here is an example. I want to calculate this integral where R is the region bounded by y equal x, y equals 0, and x equal 4. So what do you think the first thing we need, what do you think we need to do here? What's the first step then, girls? You see a question like this, what is the first thing we need to do? We need to graph, yes, we need to graph. We need to draw the graph, yes, thank you. So we need to graph what is this region so that I can find G1, G2. Remember, what I really need is what is the G1, what is G2, what is A, and what is B. Once I have all of this, then it's okay. I can then try to integrate. Okay, so first y equal x, of course. Y equal x is this line, yeah? Line in the middle. y equal x. Y equals 0. What is the y equals 0? What is the line y equals 0? It's the x-axis. Thank you, Salah. Yep, it's the x-axis. So we have the x-axis. And then x equal 4. What is the x equal 4? What line is x equal 4? It's a vertical line, yes? Vertical line parallel to the y-axis, vertical at x equal 4 like this. So this is our region. So x equal 4 is here, y equals 0 is here, y equal x is here. So this region is similar to this one, yeah? So what is G1, what is G2, what is A, and what is B? Okay, so the integral then for x, EX squared, Okay, so EX squared minus 5 sine y dA. Okay, first, let me say something here that this, I cannot integrate it with respect to x. It's not, it's impossible to find the integral of EX squared with respect to x. So I must start my integral minus 5 sine y. So I must integrate first with respect to the y, yes. Now, what is G1? Look at what's happening to y. It goes from y equals 0 to y equal x. So basically, it's going to be from 0 to x. And then, whatever this result is, I will integrate it with respect to x. And x goes from 0 to 4. That's it. 0 to 4. Like this. So that is how we are going to work out this integral. We split it into two simple integrals. So let me keep 0, 4. Now I need to integrate with respect to y. What is 4ex squared with respect to y? It's a constant, yes? This is a constant. So multiply it by y. That's it. Exactly. So multiply it by y. Okay, good. And then the integral of sine y is plus. Yeah, it's plus 5 cosine y. Yes, cosine y. And this from y equal to 0 to y equal x dx. So now let's substitute y by x. So you will get 4x, yeah, ex squared. And then plus 5 cosine x, yeah, 5 cosine x minus, substitute now, y equals 0. Of course, this will, the first term will be 0. And the second term will be 5, yes, will be a 5. So we have something like this. Now we need to see how do we integrate each term here. Now, this one what is the derivative of x squared? What is the derivative of x? 2x, yes? So think of this as 2 times 2x ex squared. So when you integrate this, so it's going to be 2 times. Now, let me go back to one of the rules I gave you a moment ago, that if you have u dash u that you want to integrate, then what is the integral of this? I just gave you a rule which says that if you have a derivative of this, yeah, EU, yeah, it's EU, like this, exactly. So therefore, here it's 2 times ex squared, yes, and then plus the integral of 5 cosine x. What is the integral of cosine? So that will give us sine, yeah, sine x, and finally the integral of 5, which will be 5x. That's it. From 0 to 4. So now you need to substitute and see what happens. So you substitute, you will get 2 times e to the power of 16, yeah, plus 5 sine 4 minus 20, all of this, minus, when we substitute with 0, we only get the first one, which is 2. The rest are all zeros. So we will get 2 e to the power of 16 plus 5 sine 4 minus 22. And that is the final answer in this integration. Now, did you understand this? Did you understand this? Yeah? So, if we look back at the example, the first thing you need to do is to graph, yeah, graph the region, this region R, you need to graph it. Then you need to determine what are the G1, G2, what is A and what is B, and then you can use the rule, this rule that we have mentioned before. So integrate, if your region is like this, X from A to B, Y from G1 to G2, then first integrate with respect to Y first, and then with respect to X afterwards. So that's the way you do that. Okay. Now, sometimes you have regions in this form where the region R is defined by X going from a function of Y, H1, to another function, H2, like this. If we did the integration, let me go back. Yes. For the line, y equal x from 0 to 4. Yeah. I'm not really sure what your question mean, Salah. Yeah. Remember what we did here is we integrated first with respect to y from y equals 0 to y equal x, and then you shift this integration with respect to y from x equals 0 to x equals 4. It's like this. So you need to integrate in one direction, maybe y direction, like here, and then in the x direction. Okay. Now, in this situation, when you have areas R, which is defined with y from C to D and x from H1 to H2, then in this situation, you need to integrate first with respect to x, and then the second step with respect to y. So let's see how it works here. Right. Okay. By the way, yes, let me just check. Yeah, okay, no problem. Now, I want to go back here. All right, so write this integral as an iterated integral. Iterated means separate it into two integrals like this. This is called an iterated integral. Where R is the region bounded by the graph x equal y squared and x equal 2 minus y. So here they're not asking us to work out the integral, just write it as an iterated integral like this form here. Okay, so what is the first step? What do we need to do here first? We need to graph. Yes, we definitely need to graph this region. X, y, yeah, like this. So we have two curves, x equal y squared. What do you think the graph of x equal y squared is? It's a parabola, but the axis of the parabola is x. Yes, so it's going to be a graph which is like this. This is the graph x equal y squared. All right. And then x equal 2 minus y. So this is a parabola, yeah, like you just said. How about this one? X equal 2 minus y. It's a straight line, yes, it's a line, yeah. And if you want to graph it, all you have to do is maybe take 2 points, yes, x, y. When x is 0, when x is 0, you can see that y will be 2. And when y is 0, yeah, x is also 2. So this line goes through the point, this point, which is 0, 2, and it also goes through this point, which is the point 2, 0. So we will get this line here. So this is x equal 2 minus y. Okay. And okay, so the region is between these two curves. So basically, this is our region, like this. So if you compare to this graph here, what is H1 and what is H2? What is H1? y squared. Yes, exactly. So we are going from x equal to y squared here to the line x equal, so h2, yeah, h2 is 2 minus y. Now what do I need now? If you look at the integral, we need to find, yes, c and d, yeah? So we need now to find c and d. Okay, c and d. This point and this point, like this. All right, so how are we going to get c and d? Well, c is this point, and D is this point. So I need to find them. Yeah, so I need now to consider the intersection of the two curves. Yeah, intersection. So you basically make y squared equal to 2 minus y. Okay, so that means y squared plus y minus 2 equal to 0. This is a quadratic equation. So you will get two solutions. If you take your calculator, or you can use any other way, you can see that one solution will be 1, and the other solution will be minus 2. And we have our C and D are here. So we will say the double integral over R of the function f. We don't have the function, so let me just write f is going to be the integral with respect to y from, so what is what from first here, so I need four things. Yeah, I need four things. What is here? What should I write? These are the curve h1. What is h1 in this case? Y squared. Yeah, y squared. So y squared sorry, it's dx, huh? It's dx. Yeah, so I'm just dx. So from y squared to 2 minus y, yeah, and then the answer, we will integrate it with respect to y from c to d, and that is basically the answer of this question. So just split the integral, double integral, into two integrals like this, and that is what we want in this example. Just write it as an iterated integral. All right, so let's try this one, and then maybe we take a small break. Let R be the region bounded by this, this, and this. And I want to find this integral in this region. So first thing we need to do here then, again, is to graph. Yeah, so we need to graph. What is this region? So y equals square root of x is a curved line. Yeah, it's like this. Yes, y equal. You need to know these curves, by the way, girls. These simple curves, you need to know them. So y equals square root of x is that. Then x equals 0. What is x equals 0? That's the y-axis. Yeah, so we are here. And y equals 3 is a line here. Yeah. Okay, y equal square root of x, and then y equals 0. Sorry, x equals 0. Yeah, x equal to 0. So basically the region is this one. Okay. Now, we can integrate. Now we want to find the integral 2x y squared plus 2y cosine x dA. So what do you think? Shall we, here it doesn't matter, we can start with an integral with respect to x. That's perfectly fine. Or we can integrate with respect to y also. It's perfectly okay. So if I want to do it, yeah, like this, with respect to x first, then it will be from x equal, like in this direction, yeah? So it's going to be from x equals 0, yeah, to this curve. I can change it, yeah, I can change this into x equal, when y is square root of x, x, if, yeah, y squared, yes, exactly. So you could do that. And then the answer, we will integrate it with respect to y from 0 to 3, like this. It's perfectly fine if I want to do it like this. You can also integrate with respect to y first. That's also fine. But if you integrate with respect to y first, then it has to be in this direction, from y equal square root of x to y equal 3, and then you integrate with respect to x, then you have to find this point here. So it's a little bit easier to do it with respect to x first. Yeah. Then it will be from 0. What do you think this point will be? Yeah, the intersection between y equal 3 and y equal square root of x. So 3 is square root of x. So x will be not 3, 9. Yes, yeah, exactly. So this point will be 9. So this will be 9. So it can be done like this, but we will do it with respect to x first. So let's complete this. Now, okay, the integral with respect to x, you have a 2x here. So what will be the integral? Yep, x squared, thank you, y squared, yeah. And you have a cosine x that you need to integrate. So it will give us 2y sine x, yeah, sine x, from x equal to 0 to x equal y squared, and then the answer integrated with respect to y. So now let's substitute. if you put x equal, yeah, so you put this substitute, so you will get y to the power of 6 and then plus, yeah, plus 2y, yes, sine of y squared. And then when you put x equals 0, this is going to be 0. So that's all there is that we need to integrate with respect to y. Now, first one, easy to integrate with respect to y. Yeah. So that will give us y power 7 over 7. Now the second one, notice that the derivative of y squared is the 2y. So in general, if you have basically you can, the same as the rule I already mentioned before, if you have u dash cosine u and you want to integrate this, then this is sine u. And if you have a derivative multiplied by the sine of u that you want to integrate, it's going to be minus cosine u plus a constant. So these are all useful rules for integrating. So here, so what will be the integral here? So it will be minus, yeah, minus cosine of y squared from y equals 0 to y equals 3, and then we can calculate this. Yeah. Be careful, you need to be in radians when you do this calculation. It really has to be in radians. Huh? So it's going to give you 3 to the power of 7 over 7 minus cosine 9. And then at 0, it's going to give you plus 1. So this is the answer. And I don't know, my calculations 314, but I may be wrong. I'm not. Can you try it? Can you see what's the answer? 314, yeah? 314 is what I have as the answer to this. Okay, so let's take a break until 11, and then we can come back and do a little bit more of this. Okay, guys. Okay then, guys. So let's complete this section by looking at this example, the last example, 1.7. We want to calculate this iterated integral. So if you want to calculate this integral, what does it mean? What is the first integration? Is it with respect to x or with respect to y? If you look at it like this, what is the first integration you need to perform here? With respect to x, yes? With respect to x, thank you. So it has to be with respect to x like this, and then the result will be with respect to y. However, we're facing an issue now. We're facing a problem here. What is the integral of ex squared dx? If you want to integrate ex squared, do we know what function we will get if we do that? No, exactly. The answer is no. There is no impossible to calculate. There is no way to calculate this. Not possible. There is no function like this. Therefore, what we want is we must switch the order of integration. So that means we first need to integrate with respect to y. But to do that, we will have to change the boundaries. These will change. So when we change the order, these boundaries will change. And to change them correctly, I need to graph. So if you look at this integral, that means x, yeah, goes from x equal y, which is this, to x equal 1. So I need to graph these two things. And y goes from 0 to y equal 1. So what is this region? So you graph x equal y, which is this. You graph x equal 1, which is this line. And then, okay. And then you can see that y will be from 0 to 1. So really what we did was basically integrate in this region. X equal y to x equal 1. And then y from 0 to 1. So this is our region, basically. So now, if I want to integrate in this region, ex squared dA, and I want to start now with y first. That means I need to integrate in this direction from y equal 0 to y equal x. And then the answer will be integrated with respect to x from, so what are the values of x? From 0 to 1. Yes, from 0 to 1. So that is basically the way we do that. So we graph and then we change the order of integration and it becomes like this. Now it's fairly easy to integrate. What is the integral of ex squared with respect to y? Because ex squared is a constant, so its integral will just be ex squared multiplied by y from y equal to 0 to y equal x. and then dx. So now substitute this here. So we will get the integral from 0 to 1 of x ex squared, and at 0 it's going to be 0. Yeah, yes, like that. Yeah, dx. Now, yeah, this is what you get when you substitute the y with x and then with 0. You get this. Now this one, what is the integral? The derivative of x squared is almost this, yes? So you could think of this as, yeah, so it's half the integral from 0 to 1, 2x ex squared dx. Now, the derivative of this is exactly this. So it's going to be half of ex squared from 0 to 1. And then you calculate this. It's basically half. And then you substitute, you get e. And you substitute with 0, you get 1. And this is the final answer of this integration. So sometimes you will see these kind of questions where you need to switch the order of integration. That means you need to change the order of integration. But to do that, you need first to graph the region and see, yeah, change the way x and y are varying. And that's basically what happens in this section. Let's continue perhaps here. This exercise fairly simple. I want to integrate with respect to y first and then find the integral with respect to x. So let's do it. What is the integral of x with respect to y? xy, thank you. Good. And then the integral of 2y with respect to y is y squared. Great. From y equal to 0 to y equal to x dx. So substitute now. Substitute. Yeah. So that will give us the integral from 0 to 1 of 2x squared. Yeah. 2x squared. So not x cubed. Huh? Yeah. And okay, 2x squared. And when you substitute that here, yeah, okay, no, substitute with 2x, so you will have x multiplied by 2x, yeah, which is 2x squared. So, okay. And then we substitute with 2y, y with 2x, yeah, it's okay, which will give us 4x squared this time. And then you integrate that with respect to dx, and so it will be 2 over 3 x cubed. Oh, okay, what? I can put them together, so 6x squared. So it's 6x squared that you want to integrate. So it's going to be 6x3 over 3 from 0 to 1, which is 2x cubed from 0 to 1. So final answer is 2. Yeah, fairly simple. No major issues here. Yeah, okay, great. Now, okay, I will leave you this. That's not a big issue. You can integrate that without any problems. So first you integrate with respect to u, and then you integrate with respect to t. A very similar idea. Here, same thing. You can integrate. So let's try and do this one, maybe. So with respect to x, so keep 0 to 2. Yeah. What is the integral of e to the power of y squared with respect to dx? Just multiply by x, huh? So because it's a constant, so it will be x e y squared, like this. And that is from x equal to 0 to x equal to y, like this, dy. Okay, and then you substitute. Yeah, so you substitute this x into here. So you will get 2y ey squared, and the 0 will give you 0, so no need to write it. So we're getting this. And now, this is now very convenient, because what is the derivative of y squared? It's 2y, which is exactly there. So this integral is what? Just e y squared. Thank you. Yes. From 0 to 2, like this. And you substitute. So it's going to be e to the power of 4 minus 1. Very easy. No problem. Are you okay with this? Yeah? All right. Good. Okay, I will leave this. You can try it yourself. Fairly easy. Now this one, we want to find an integral. Yeah. Okay. Equal to the volume of the solid bounded by the surfaces, and evaluate the integral. Okay. So we need to basically get the volume. By the way, the volume is the double integral over the region R. Yeah. Yes. Length, width by the height. Yes. But in general, if you have a function, yeah, let me explain a little bit what's going on here. So imagine you have a region R in the XY plane, a certain region R, and in this region R, you have a function defined f of xy. Yeah, its value. So you have a function z equal to f of xy. So its value will be values of z, like this. So you will have, yes, its graph is going to be a function, a surface like this. Now, then you have this solid. Yeah, you have this solid Yeah. Then the volume of this solid, the volume here, is the integral of the function f over the region R, like this. This is very similar to, in one dimension, when you have a function y equal f of x, and you want to find the area between or under the curve from A to B, then the area, like you said before, is the integral from A to B of f of x dx. So in two dimensions, we're talking about the volume. In one dimension, like this, you have area, like this. So that's the general idea about these volumes. The volume will be the integral of your function f, which is given here. What is the function f in this example, by the way? What is f of xy here? Yeah, z, which is what? Which is what is in the example 25 here? What is the function f of xy? X squared plus y squared, exactly. So basically, the volume will be the double integral over R of x squared plus y squared dA. So that is going to be the volume. Find the volume, yeah? Okay. Now, if we want to evaluate this integral, then what do we need to do? So we want to evaluate this integral. We want to find the value of this integral. Then what's the first step we need to do here? Yeah, we need to basically graph the region R. Yeah, we know how to find double integrals, but we need the region R. We need to find it. The region R is given by basically y equal x squared and y equal 1. Z equals 0 means we are just on the xy plane. So let me then uh, y equal x squared and y equal 1. So no, I want to open a new page. So R is bounded by the two curves y equal x squared, which is this curve, and y equal 1, which is this curve. So here is the region R, which is, so I want now to find the integral over R of x squared plus y squared dA. Now we need to split this into two integrals. Now, do you think we need to integrate first with respect to x or with respect to y? What do you think? With respect to y, yes. Y is the correct answer because we can integrate with respect to y from y equal x squared to y equal from here to here to y equal 1. Yes, thank you. Like this. And then, whatever the answer, we will integrate it with respect to x. But now, for x, I need to find these two numbers. That means I need to solve x squared, yeah, y equal x squared and y equal 1 together. So x squared is 1, which means x is plus or minus 1. So we need to integrate this from -1 to 1, like this. Now we can integrate, I think, without too many problems. So let's see. So it's going to be from -1 to 1. What is the integral of x squared with respect to y? With respect to y, yeah? We're integrating, remember, so it's x squared times, no, times y, yeah? You need to multiply by y. It's a bit like integrating 5 with respect to x, so it's going to be 5x, yeah? Plus a constant. So you always have to add the, okay, all right, fair enough. And then we have the y squared. Y squared, we need to integrate it. So it's going to be y power 3 over 3. So from y equal x squared to y equal 1. And all of this then integrate all of this with respect to dx. Okay, great. Now we need to substitute. Yeah. So when I put y equal 1, I get x squared plus 1 over 3, so like this. Then minus, I put now y equal x squared, and I will get x to the power of 4, yeah, good, and plus x to the power of 6, yeah, over 3 dx. Okay, now I need to integrate each one of these terms. X squared will give us x3 over 3. Yeah, 1 over 3, yeah, will give us 1 over 3x. Then minus x to the power of 4 will be minus x 5 over 5. And finally, minus x 7 over 21. So, okay, from -1 to 1. This now is a calculator work. You can use your calculator and you will see that we get 88, I think, over 105. This is my answer to this calculation. Okay. I will do one last one to the. Are we okay with this? Any questions? Yeah. Okay, great. Okay, I will do one last example, which will be 27. The same thing. I want now the function is given here, and the region is given here. I want the volume. So again, the volume will be, we need to graph, but let me write first what we really want is to integrate over the region R, which will come from here. The function, what is our function this time? 6 minus x minus y dA. like this. So that is actually what we want to calculate. Then the next step is to look at the region itself. X equal 4 minus y squared is a parabola, yeah? It's a parabola and it's going through the point 4 here, and its axis is the x-axis. So it's a parabola like this, 4 minus y squared. And x equals 0. So this is x 4 minus y squared. And then x equals 0 is the y-axis. Yeah, it's the y-axis. So the region R is here. So this volume then will be the integral over R. Now, if you want to integrate in this region R, look at it the way it is. Is it better to start with integration with respect to X or Y? Yes, X is better, yeah? So we integrate with respect to X from X equal what? X equal 0, yeah, which is this curve, to 4 minus y squared. Good. With respect to like this. And then with respect to y, and for here, we need to find, yes, we need to find the 2 points. So we need to solve 4 minus y squared equal to 0, which will give us y squared equal to 4, which will give two values of y plus or minus 2. So we will put them there. And then I think the rest is fairly easy because the function to integrate is simple. So we integrate it with respect to x. So it will be 6x, yeah, good, minus x squared over 2. And then y will be xy. Yeah, thank you. Good. From x equal to 0 to x equal 4 minus y squared. After that, dy. We substitute. Yeah, it will be 6, 4 minus y squared minus 4 minus y squared squared over 2 minus x times, no, sorry, not x times, but yeah. So minus 4 minus y squared, yeah, times y, yes, times y. And then when you put 0, they are all 0, so no need, like this, dy. And then you need to open all these brackets, simplify, integrate. I will just give you the final answer. It can be done. It's not a big issue here. Just you can complete it. So that's sorry, it's 704, not 5. 704. You can check this, please. 704 over 15 as the final answer of this calculation. Okay, so we stop here. Okay, that's it. Thank you very much indeed. Thank you for your patience. I hope you can go back and review a little bit this. This section will be in your test, by the way. That's it. The test will stop here. Anything we will do from now on will not come in the test. So, yeah. Is it 173 over, okay, 176 over. Yeah, I think you may be right. I don't know why. I don't, yeah. Okay, let me remove this. You may well be right. I don't see why the 15 is coming from. Yeah, okay. Yes, okay. So I will leave you this. You can calculate it. Yeah, I don't know where. No, it's not that 15. No. Yes, you need to integrate with respect to y this. Yeah. But first you need to open all these brackets and maybe simplify things a little bit, and you should get the answer without too many problems. If you have any problems with this, let me know. Okay then, thank you. I'm really sorry about this test, girls. It's I cannot move it. I'm absolutely no possibility at all. No. Yeah, I'm really sorry about that. But it has to be done on Tuesday. Believe me, it does not make any difference. It really does not. Absolutely no difference. Your test will be very similar to the practice test. The other section and your section will have different numbers, different things. So it doesn't really matter. You know, this practice test for section 59, test for section 60, they're all very similar. Yes, they're all very similar. All that is different is numbers. So just do the practice test and you will be fine. Okay. So please focus more now on reviewing. I will post the review test for you. Next week also I will review, and hopefully you will be fine. Yeah. So don't worry about that. So just focus on reviewing. Everything will be okay. Alan, have a nice day. Have a nice weekend, and I will see you next week, inshallah.